Now children, in this video we will study about sigma and pi bonds. They are the special type of covalent bonds. What is sigma bond? Sigma bond is shown by this, pi is shown by this. What is sigma bond? When we have two s orbitals or one s and one p orbital or two p orbitals overlapping head on or axial overlapping, they give rise to sigma bond. And when we have two p orbitals having this way, lateral overlapping or sidewise overlapping, it gives rise to pi bond. So this is formed by axial or head-on overlapping of SS, two s orbitals, or one s and one p, or two p orbitals, but along x-axis. Then only they can have head-on overlapping or this axial overlapping. That's why I wrote precisely px orbitals. Otherwise, it can be any two p orbitals. I repeat, any two p orbitals, but undergoing axial overlapping like this. Or say head-on overlapping or overlapping along x-axis, they form sigma bond. Pi bond is formed by sidewise or lateral overlapping like this. Sidewise or lateral overlapping like this. Okay. So this is sidewise overlapping, two p orbitals, they give rise to pi bond. Formed by sidewise or lateral overlapping of two half-filled p orbitals. And this is by head-on overlapping of two half-filled s orbitals or one s and one p or two p orbitals having overlapping along x-axis or say axial overlapping or say head-on overlapping. Then children, since in sigma bond the overlapped area is greater, overlapping is greater, head-on overlapping, almost complete overlapping, head-on overlapping, overlapped area is greater, the bond is strong. And in pi bond, this is lateral overlapping, sidewise overlapping. You see it's difficult to overlap. So children, here, since the overlapped area is lesser, overlapping to lesser extent, hence it is a weak bond. So pi bond is a weak bond. Then there's free rotation of atoms about the sigma bond. Atoms have free rotation in case of sigma bond about its axis. Free rotation of atoms about sigma bond. But in pi, there's no free rotation at all possible. Either it is hindered or restricted. In case of pi bond, we do not have free rotation of the atoms around the bond. It is either hindered or restricted. Then this can be formed independently. Children, whenever a single covalent bond is formed, first covalent bond is formed, it is always sigma. And when once single covalent bond is formed, then the remaining bonds what are formed there between the same two atoms, they are pi bond. So sigma bond has independent existence, can be formed independently. But pi bond cannot be formed independently. First, sigma has to be formed, then only you can have pi bonds. Like this, children, I tell you, suppose we have say C triple bond C. So first bond which is formed between carbon, this is sigma bond, this is sigma bond. Out of these three, children, the first covalent bond which is formed would have been sigma bond and the remaining two will be pi bonds. So let's say this is our first sigma bond and the remaining two are pi bonds. Got it, children? So when we have multiple covalent bond, like I have double covalent bond. In double covalent bond, first bond is sigma, second is pi. In a triple covalent bond, first bond is sigma and remaining two are pi. And when we have single bond, single bond is always sigma. The single bond, sigma bond has independent existence. But when we have multiple covalent bond, like double covalent bond or triple covalent bond, the first bond is sigma and the remaining bonds formed between the same two atoms are pi bonds. Like here it is sigma, here it is sigma. Single bond is sigma. S for single, S for sigma. But when we have double or triple covalent bonds, so when we have double covalent bond, first bond is sigma and second bond is pi bond. So here, if we have triple covalent bond, first bond is sigma and the remaining are pi. So children, it is formed by axial or head-on overlapping. Here it is lateral or sidewise overlapping. Strong bond because greater overlap area. Weak bond because it is lateral or lesser extent of overlapping. Then free rotation about its axis of the atoms, and here no bond rotation, no free rotation of the atoms about the bond. It is either hindered or restricted. It is because of this, children, I gave you one point that covalent compounds show isomerism. This is, or rather, stereoisomerism. It is one of the reasons why those compounds, they show stereoisomerism. Now you will say, what is a stereoisomerism? You did not explain us that time. Don't worry. This will be taught to you in the chapter isomerism. You have to wait for that. So children, the term is there that yes, covalent compounds or compounds having covalent bond, they show isomerism. Especially stereoisomerism. That was one of the cause there. Here, one of the factors there, one of the properties there. So this is one of the reasons those compounds, they show stereoisomerism. Right, children? So compounds having covalent bond, they show isomerism. So this is the point here. Isomerism means, compounds having same molecular formula but different structures. Details will be taken up later on. So when two s orbitals combine, 1s and 1p combine, or 2p head-on overlapping, it gives rise to sigma, and when 2p orbitals lateral overlapping, it gives rise to pi bond. So this is all for your sigma and pi bonds. In my next video, I will show you how to count sigma and pi bonds. That is also often asked. So I hope these points are clear to you. You will note down. For this video, I stop here.